Shrimp and flamingos seem completely unrelated. One lives underwater, the other wades through shallow lakes and wetlands. One is small and translucent, the other tall and unmistakably pink. But they are connected by the same invisible mechanism, and without it, flamingos would not be pink at all. In fact, flamingos are born gray. Their color is not genetic in the way people often assume. It is built slowly through diet, using the same compounds found in shrimp and other small aquatic organisms. The key to this connection is a group of pigments called carotenoids. Carotenoids are naturally occurring compounds found in plants, algae, and some bacteria. They are responsible for many red, orange, and yellow colors in nature. Carrots are orange because of beta-carotene. Tomatoes are red because of lycopene. In aquatic environments, certain algae produce carotenoids as part of their normal metabolism. These algae are eaten by tiny organisms like plankton, brine shrimp, and small crustaceans. When shrimp consume algae, the carotenoids accumulate in their bodies. Shrimp do not create these pigments themselves. They absorb and store them. On their own, shrimp often appear gray, greenish, or slightly pink depending on species and environment. But the pigments are there, even if they are not immediately visible. Flamingos enter the picture one step later. Flamingos feed on shrimp, plankton, and algae-rich water using specialized beaks designed to filter tiny particles. As they consume these foods, they ingest large amounts of carotenoids. Inside the flamingo's body, these pigments are processed by the liver and deposited into feathers, skin, and beaks. Over time, the pigments build up, gradually turning the bird pink. The more carotenoids in the diet, the stronger the color becomes. This is why flamingos raised in captivity must be given carotenoid-rich diets to maintain their pink coloration. Without it, their feathers fade back toward pale gray or white. Color, in this case, is not decoration. It is a signal. In many bird species, brighter coloration is associated with health, nutrition, and reproductive fitness. A flamingo with vibrant pink feathers is often one that has access to abundant food and is in good physical condition. This makes color a form of biological communication. The same pigments that color flamingos also affect shrimp in subtle ways. When shrimp are cooked, heat changes the structure of the proteins that normally bind carotenoids. As those proteins unravel, the pigments become visible, turning shrimp pink or orange. This is why raw shrimp look gray, but cooked shrimp turn bright pink. The pigment was always there. Heat simply reveals it. This shared chemistry explains why many animals across different environments display similar colors despite having no close evolutionary relationship. They are not producing the color independently. They are borrowing it from the same chemical source. Carotenoids move through food chains, from algae to shrimp, from shrimp to birds, shaping appearance along the way. Flamingos are one of the most visible examples of this process, but they are not unique. Salmon, crabs, lobsters, and even some insects rely on carotenoids for coloration. None of them create these pigments from scratch. They all acquire them through diet. This dependency has consequences. Environmental changes that affect algae populations can ripple upward. If algae decline, shrimp populations change. If shrimp availability shifts, flamingo coloration and health are affected. What looks like a cosmetic trait is actually linked to ecosystem stability. So when you see a flamingo's pink feathers, you are not just seeing a bird's color. You are seeing algae, shrimp, water chemistry, and food availability translated into visible form. Shrimp and flamingos share this secret not because they are connected directly, but because they participate in the same biochemical pipeline. Color flows upward through the food chain, and once you understand that, the pink stops being mysterious. It becomes evidence. If you enjoyed this explanation, the next story explores another everyday color that isn't what it seems. Click on the channel to discover more untold stories behind simple things.